Scala is a hybrid programming language that supports both object-oriented programming and functional programming. It supports classes and they work exactly as you would expect them to work. Indeed, the implementation of ADTs is a special type of class, the case class. Now let me show you how to encode ADTs using case classes. First, we will encode the piano natural numbers. What we do is we first create a sealed trait called myOtherNat, and then we can create a case object myOther0 extends myOtherNat, and a case class myOtherSuk that takes myOtherNat as a parameter and extends myOtherNat. So we have created now the same thing as we had with the enum that we did before. Now, as you can see, we are used the sealed. Now we save to check that everything compiles. We see that we have the sealed trait. That would be the equivalent to the enum price in this case. And we have the case object that would be for the constant parts of the IDT, and the case class that would be like the parameterized variant of the ADT. Using this, we can now create the same concrete product but with a much more nicer syntax. We would just create a case class called myProduct that has exactly these parameters here. That way, we don't need to have this import product and the class is directly in scope. We save once again to check everything that everything compiles. And this is the way that we use classes to define ADTs. In fact, when you write this will be translated to this syntax by the compiler. As a consequence, these special classes have the same features and limitations that we have seen before. First, they can only be extended in the same file as the main definition. That's what the sealed keyword is for. Second, all the fields in the constructor are immutable and public. And third, they allow to use the copy method. If you look in the Scala documentation, you will also notice that we can add methods to ADT. This feature is very practical in certain situations. One thing that you would be tempted to do, if you know already that in the end enums are classes, you would be tempted to do something like define an isEmpty here that returns a boolean and then override it over here and here. But that's not possible with enums. Enums will force you to do it the ADT way. That means that, for example, you do a match to check if this is either empty or a constructor. However, you can do that if you are using case classes. Let's say, for example, we have a sealed trait for myOtherList, takes an A, and now we do a case object myEmpty extends myOtherList of nothing, and a case class myCons of A takes a and a tail. This is myOtherList of A, and extends that and extend myOtherList again. Now we can do this, like def isEmpty boolean and have it. Let's save it. This is extends, and now we can override def is empty, false or true, and we can do the same here. Override def is empty, false. So we have exactly the same thing, and this syntax will allow us to do the override thing, and this one will not allow us. I personally like it more with the enum syntax because that is the ADT way. It's not, you don't do an inheritance to do what you can do with pattern matching or using the ADT tools that you have at your disposal. So I would say that the functional way is using a match, and Scala will give you the option to do it the object-oriented way if you use sealed trait. And that's it. That's all I have for today. Thanks a lot for watching this video. If you arrived at this point, please subscribe to my mailing list where you can learn each time I publish a video or a blog post using the link in the description. You can also subscribe to this YouTube channel by clicking on the subscribe button below. And thanks a lot for watching, and see you soon.